Hi, today I'm going to talk about the Machine Learning Foundation for Product Manager course. The objective of this course is to determine what type of machine learning approach is needed and select an appropriate output metrics to evaluate the performance. We would also determine the possible features to use in the model. I've also split the data into training, validation, and testing dataset. And finally, we'll evaluate the best model for the performance. Here's the problem type and output metric. We are using the regression model for this problem, where we need to predict the net hourly electrical energy output in the form of P in megawatts. We have four different input features: temperature, exhaust, vacuum, ambient pressure, and relative humidity. And the target is electrical output. The algorithms we'll be using here is linear regression. We have a total of 9568 records. We have split it into training data, validation data, and test data. We'll be using two different models. The first model will use all the four input features, and the second model would use temperature, exhaust, vacuum, and relative humidity. For validation approaches, we are going to use the root mean square error, mean absolute error, and mean absolute percentage error. Here is all the data which we have, the 9568 records. We have split it into multiple tabs. The first one is the training data. The training data, we have calculated the predicted PE value based on um, all the four parameters. So we have run the linear regression in the Excel, which shows this data. We have a RMSE, which is the square root of the MS, and the standard error, which is 4.49. We have calculated the MAPE and MAE with the help of this data. Then we have the validation data, where we have calculated the same values using the formula for PE predicted and then calculating the prediction error, error square, MAE, and MAPE. Similarly, we have calculated the test data. We have used this approach for this another set of training data, which uses just the three variables, which is temperature, V, and RH, and calculating the PE. And similarly, we have done the analysis, um, the validation data set, and finally the test data. Based on this, these are the final results which we have come up with, where we use the training data, validation data, and testing data from model A versus model B. Based on all of this, a recommendation is to use the model 1, which is slightly better, which has a RMSE of 4.82 in validation data versus 4.84, which is basically our most critical evaluation metrics. The added feature ambient pressure contributes small but consistent gains, and the trade-off is in complexity is minimal. That's it for this project. Thank you.